Some moments in exploration redefine what's possible. The 10th flight of SpaceX's Starship was one of them. On a warm Texas evening, a colossal rocket roared to life, not just to reach space but to reignite a dream after a year of setbacks. This wasn't just another test, it was a statement: the path to the moon and Mars is still within reach. Starship Flight 10, with Ship 37 atop Booster 16, marked a crucial turning point. After a string of explosive failures, the world watched, questioning if this vision was viable. This flight answered, yes. It completed its mission profile: flawless launch, controlled splashdowns in 2 oceans, and for the first time, opened its payload bay in space to deploy satellites. This was the moment Starship shifted from prototype to precursor of a true workhorse for humanity's future in space. Starship isn't just an upgrade, it's a fundamental redesign of how we access space, aiming for full and rapid reusability. Lowering launch costs could turn building a city on Mars from fantasy to engineering challenge. Every milestone, engine relight in space, controlled re-entry, soft landings, brought that vision closer. This flight inspired everyone invested in space exploration, reminding us that progress is built on perseverance. It was a testament to the thousands who solved impossible problems to make this happen. More than a test, it was a beacon of hope for all of humanity's future in space. The journey is long, but Flight 10 proved we're on the right path. To appreciate Flight 10's triumph, we must remember the tough road leading here. 2025 was brutal for Starship. High-profile failures tested SpaceX's resolve. Flight 7 was lost to violent vibrations. Flight 8 failed after launch. Flight 9 lost control during re-entry. Each failure was public, fueling doubts and immense pressure, especially with NASA's Artemis program depending on Starship. But SpaceX's philosophy is to learn fast. Each explosion provided data, not defeat. Engineers dissected every issue: resonance, hardware, pressurization, and structural failures. They poured these hard lessons into Ship 37 and Booster 16. This mission was their shot at redemption, to prove their approach worked. Flight 10's success wasn't luck. It was the result of relentless iteration and resilience. The world watched as SpaceX turned setbacks into stepping stones. The team's unwavering commitment solved some of engineering's hardest problems. Flight 10 was proof: rapid development, learning from failure, and never giving up pays off. The comeback was complete. The historic flight began at Starbase, SpaceX's launch facility on the Texas coast. Super Heavy Booster 16 and Starship S37 stood nearly 400 feet tall, ready for their moment. After delays from ground issues and weather, launch day finally arrived. At 6:30 p.m., 33 Raptor engines ignited, and the rocket thundered skyward. One engine shut down early, but built-in redundancy kept the mission on track. The goals were ambitious: successful ascent, hot stage separation, and new capabilities. S37 would open its payload bay in space, deploy mock Starlink satellites, and relight an engine in orbit. Then it would attempt a controlled re-entry and soft splashdown in the Indian Ocean. Booster 16's task: flip, boost back, and soft splashdown in the Gulf of Mexico. No risky tower catch, just data on landing under extreme conditions. Every second of the hour-long flight was packed with critical tests. This was the most complex and demanding Starship mission yet. The stakes, and the anticipation, were sky-high. High above Earth, Starship S37 made history. For the first time, its massive payload bay door opened in space, a gateway for satellites, cargo, and, one day, habitats. 8 mock Starlink satellites floated out, proving Starship could deliver payloads too large for any other rocket. This was a crucial milestone for SpaceX's business and future missions. Next, S37 relit a Raptor engine in space, a foundational capability for reaching higher orbits, the Moon or Mars. Reliable in-space engine restarts are essential for deep space exploration. These achievements, payload door, satellite deployment, engine relight, were a quantum leap. Previous flights focused on launch and re-entry. Flight 10 showed what Starship can do in space. It was a glimpse of a future where starships deploy satellites, deliver telescopes, and build off-world outposts. This mission proves Starship is ready to do real work in orbit. The era of Starship as a true spacecraft had begun. The possibilities are now within reach. While S37 soared, Booster 16 faced its own test. After separation, it aimed for a splashdown in the Gulf of Mexico. not for recovery, but for data. The boostback burn reversed its course, grid fins steered it, and the critical landing sequence began. The booster flipped from horizontal to vertical, engines firing for a soft touchdown. SpaceX pushed the envelope, testing engine redundancy by shutting down a central engine and using another for final deceleration. These off-nominal tests are vital for building a robust, reusable system. Onboard cameras captured the booster's engines firing just above the ocean, slowing it for a gentle splashdown. It stood upright briefly before tipping over. Mission complete. No chopstick catch this time, the focus was perfecting the landing phase. The data gathered is invaluable for future reliability and safety. Each test brings SpaceX closer to routine booster reuse. The daring dance was a resounding success. S37's toughest challenge was re-entry, a trial by fire. SpaceX intentionally removed some heat shield tiles, exposing the steel hull to test its limits. New metallic tiles and smoother edges were also tested to improve future designs. The re-entry trajectory was aggressive, maximizing stress on the rear flaps. At 90 kilometers, an explosion in the engine compartment damaged a rear flap. For a moment, the mission hung in the balance. But the flight control system compensated and S-37 continued its descent. The ship's resilience proved it could survive significant in-flight damage. This re-entry was one of the most data-rich in Starship's history. The lessons learned will shape future vehicles and missions. Spaceflight is risky, but Starship is being built to handle the unexpected. The trial by fire was a triumph of engineering and learning. The mission's finale played out in two oceans, thousands of miles apart. In the Gulf of Mexico, Booster 16 executed a gentle splashdown, upright for seconds before tipping over. This controlled landing proved the booster could manage its descent with precision. Hours later, S-37 prepared for its own grand finale in the Indian Ocean. After surviving re-entry and an explosion, it slowed with its flaps, performed a belly flop, then flipped upright for landing. For the first time, the world watched a Starship execute a powered, controlled landing. The ship touched down upright, a gleaming steel monument to a nearly perfect mission. Waves tipped it over and it exploded, but the soft landing was the real victory. The data from both splashdowns is invaluable. For the booster, it confirmed landing profiles for future tower catches. For the ship, it proved precise. Controlled landings are possible, on Earth, the Moon, or Mars. S-37's upright landing was visual proof the system works. The era of end-to-end Starship missions had arrived. Flight 10 wasn't just a step, it was a leap. Previous flights ended in partial success or fiery failure. None completed the full mission profile. Flight 10 broke the pattern, first to deploy a payload, relight an engine in space, and land both booster and ship with precision. The mission integrated all the hard-won lessons from past failures. It wasn't just about avoiding explosions, it was about demonstrating control at every stage. The ascent was stable, maneuvers flawless, and even an in-flight explosion couldn't stop the landing. The flight control software's ability to compensate for damage showed a maturing system. This success changes the Starship narrative from "will it work?" to "what's next?" The data and confidence gained paved the way for tower catches and landings back at Starbase. The rapid, iterative approach is working. Flight 10 will be remembered as the turning point. Starship is now a proven system, ready for the next phase. The future of space access just got a lot closer. The impact of Flight 10 reaches far beyond SpaceX. NASA, relying on Starship for Artemis lunar landings, now has renewed confidence. Key milestones, engine relight in space, controlled soft landing, are essential for lunar missions. This flight proved the architecture is sound and the timeline for returning to the moon is more achievable. Starship is the only system in development with a real shot at making humanity multiplanetary. The dream, a self-sustaining city on Mars, made possible by a fully reusable rocket. Lowering launch costs is the key to building outposts on other worlds. Flight 10 was a giant leap toward that dream. It reignited our imagination and proved what's possible when we persevere. The path to the moon and Mars is clearer than ever. The journey continues, and we're one giant leap closer to the stars.